your standard form stuff. Ax squared bx plus c. We also looked at vertex form, and we also looked at intercept form, or working with zeros. What we're going to do this week to start out with are two other ways of doing it. I alluded to this last week, saying that we're eventually going to start having parabolas that turn. We know we have up like a cup, down like a frown. We can also have ones that go right and go left. All these parabolas have certain properties, things that we haven't quite worked with yet. And what we're going to work with today are going to be parabolas that are always going to have a vertex at the origin to start with. Then we're going to adjust them according to some values here in a little bit. So for today, everything's going to be at the center and go off of that. Well, what's going to happen here is that with every parabola, I'm just going to use one off of a regular up like a cup parabola. Every parabola has the same kind of things. There's always a vertex. And this is where some of the new terminology is going to come into play here. Vertex, your curve comes out of the vertex. We agree on that, right? What I want you to think of, Chris, can I steal your glasses for a second, please?
Sure.
Glasses are curved, so that way you can focus at something, correct? They're bent, they're curved for everybody to have a different focus spot. Same thing with contacts. Contacts are curved in such a way that you can have a spot you can actually see. Now, for every person's eyes, they're all a little bit different. Everybody's got a little bit different prescription for the curvature, how things are shaped, how the glasses are bent in. Thank you, sir. What's happening here is that these curves are allowing you to look at what's called a focus. You can see the board better when you have your glasses on because it's in focus. So every curve is always looking at what we call a focus. Whether this is up like a cup, down like a frown, turning left or turning right, the curve itself is always going to be looking towards a focus. Now, what I want you to think of here is that within every, if you have a focus, you have to have something behind it. You guys all know how your eyesight works, right? Yeah. How your eyesight works, where it comes in and it bounces back out and whatever. There's some value back here that the image is kind of stabilized against. I don't know if I can't think of the right word. This value, in terms of math, is called a directrix. And if I'm up like a cup or down like a frown, I've just drawn a horizontal line, correct? What's the equation of every single horizontal line? Y equals something. So this is always going to be y equals some number. Okay? So one thing I want you to see then, no pun intended with focus here, is that this distance from the focus to the vertex will always be the same as the distance from the vertex to the directrix. Those guys are always going to be equidistant to the vertex. It keeps it balanced, if you will. What's going to be kind of cool with this is that you're going to be able to use these same values. Now today, like I said, everything's going to be centered at the origin. Our vertex is always going to be at 0, 0 for today. We're going to work on writing equations and graphing things a little bit differently depending upon a focus or a directrix, because it gives you enough information to set the curve. Okay? This is going to be the same type of information if I spin it this way. My focus is, my curve is still opening downward. I'm still looking to the focus. My directrix just happens to be above me now. But what changes is when I'm going right or left. What changes with my directrix? It becomes, instead of a horizontal line, it's a vertical line. So what is the, actually, is it x equals or y equals? It's an x equals. Okay? That's the only real thing that changes. Your focus, if my curve is going to the right, I'm still looking at it. If I'm going to the left, I'm looking at it. Does that make sense?
Yeah.
And obviously this becomes an x equals a number if I'm a horizontal curve. All right? This gives us two new forms of an equation. Let me do this. This is going to give us two different forms of equations. We're going to have an x squared equals 4py. And we spin this. And this is a y squared, bless you, equals 4px. What I'm doing here is showing you guys two different ways that we're going to write these. You guys have all worked with x squared parabolas. That's what we've mainly been working on the past week or so. All the quadratics, everything was always x squared, ax squared, bx plus c. What's going to be different now today is that we can have y squared parabolas. Just a little bit of a different. So here's what's happening. This value of p, is the distance from the vertex to the focus. And that's no matter either equation. So if p-value is positive, is it going, for an x squared, is it going to be going up or down? Up. If the p-value is negative, that means it's opening down. Okay. Same thing with the left and right ones. If p-value is positive, what direction do you think it's going? Correct. It's going to move to the right. And if the p-value is negative, it would be opening to the left. Because your vertex is always going to open towards the focus. So that p-value tells you which way it's going to go. If it's a y squared, it's positive, it goes to the right or up. And if it's negative, it goes left or down. If you think of the number line, it just follows right along suit. Okay. Now, if I'm looking at just this, if I'm looking just at this basic equation here, where's my axis of symmetry on this guy, on this one? Y equals 0 or x equals 0? Does everybody see how my axis of symmetry is at x equals 0 because I'm at the origin here? So my vertex is at 0, 0. What's the coordinate then for my focus? Zero something. Well, what's that something? P. The focus is at 0, comma, p. Okay? Because it's on the axis of symmetry. And then my directrix is going to be at, that's a point. If I'm going to write the line, then it'd be just y equals, is it, slow brain. If this distance is p, this distance is also p. It's a horizontal line through that point, so it would be y equals negative p. Because it's the opposite, it's below it. Okay? And if it was spun around, the y equals would be up here, and then the focus would be at negative. Does that make sense? Yes, sir. It's the line. The directrix is the line. All right? And then it's just going to be flip-flopped with the x squareds. Instead of being at my focus now, my focus here would be at, p, comma 0, because it's on the x-axis. And my directrix would be x equals the opposite of p. Well, this doesn't do a whole heck of a lot of good right off the bat until you start to see how it works. Yes, sir? Oh, okay. Let me show you a very simple example. If I have the y squared equals 16x, I'm going to walk you through how you set this up, graph and label everything you need to know. First question I'm going to ask you, is this an x squared or a y squared parabola? It's y squared. This is a y squared parabola. So when I do this, after I notice it's going to be a y squared parabola, I'm going to write down the generic form for the y squared parabola. Okay? Very good. To figure out what p is, you take the coefficient here, and you set it equal to 4p. The x is just a variable. Okay. That's all it is. It's just a variable, correct? I'm looking at the 4p is think of it as the coefficient. That p value comes out of the 16. So what's p? P is 4. I have no idea. They're out of letters.
I don't just make it.
I don't know. So we're going to say that p is equal to 4. Now, we know it's a y squared parabola. P is positive. What direction does this open?
Right.
To the right. Okay. So here's what we're going to do. We know it's going to open to the right. I know my vertex is at the origin. So I'm just going to do this for right now. I don't know where my points are yet, but I know that it has to open to the right. Everybody okay with that? Yes, ma'am.
We know that it's at the origin because these.
Everything's set at the origin to start with. Yeah.
So these equations are only with the origin ones?
The same thing will happen when we shift things later. It'll still work. There's just going to be an added h and k to this.
Okay.
Okay. And then instead of being at 0, 0, it'll be at, and we just walk things off of that.
Okay.
If we get this down by figuring out where things are, how the relationships occur with P and your vertex, the rest of this chapter, or the rest of this stuff is very simple.
It's to the right.
It's positive. Yep, it's right because it's positive. So there's my P value. So my focus is at 4, 0. My vertex is at 0, 0. Where's my directrix? What equals negative?
X.
X. Oops. For the focus? You don't have, I mean, you can if you want. I'm just drawing it up here. So there, it's at. So I've got a vertical line. And you guys notice how I'm drawing my directrix as a dotted line?
Yeah.
Okay. Make sure you draw it. That's kind of the customary way of drawing it. So we've got my focus, the directrix, and the vertex. What am I missing? Just get a set of points. Now, your calculators, and I don't spend a lot of time worried about point values here because you've got a button that says y equals. You don't have a button that says y squared equals though, do you? So if I wanted to put this into my calculator, what do I have to do? All right, good. So if you go to your calculator, if you just type in the square root of 16x, and just hit graph so you get the idea of what it looks like.
I didn't get half.
Why do you only get half of it?
You only got the plus side.
I only have the plus side in there. Remember when I took a square root over an equal sign, I had to do plus minus? Remember that? There's no button for that. You'd have to type it in twice. But here's the thing. You're only getting one curve because we just took the positive value of it. Wouldn't there always be a symmetric twin down below?
Yeah.
Symmetric twins still occur. Okay? It's not going to be all that scary. So if I'm using, let's make a really easy thing. What if x is equal to 1? What are your y values?
4 and 1.
If x is at 1, y squared equals 16. So y would be at positive and negative 4. And like I said, I'm not all too worried about getting ordered pairs because the table value of your calculator will allow you to do that. What's up? I just picked a pair.
Oh, yeah.
We did symmetric twins, but instead of being, up like
I
a...
forgot that it was y squared, so I was
Yeah.
confused.
And that's the whole thing is when you take the if you have a y squared parabola, If you just put in the positive part of it, you'll get that one. If you put in both equations, you'd have to do it twice. It'll work, but why bother? If you need to get an ordered pair, it's just remember that you have a symmetric equation. And we'll worry about shifted things later. You had a question? Glad I could help that out. Okay. Now, the goofy part of some of these things, though, because there's always a goofy part, comes in is when it's a fraction. I know I typed it in, I didn't have anything to write with. And I don't want graph paper. Graph paper's a waste. Okay. What's that? You don't need graph paper for this. You don't need graph. I don't want you to have graph. Okay. I want you to do visual representation. I just want you to do visual representations. Okay, rough sketches. That's all we're worried about. So I do the same thing. Is this an x squared or a y? Yes, sir. Oh, no, 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 no. Michael had a great question here. You guys remember how when I was drawing here, this little squiggly thing, I use that a lot to show that they're going to be equidistant. You don't have to draw that in. There's a reason that I have these little curves in here. When we get into graphing some of the ellipses and the hyperbolas, you'll see all these different relationships, how things are interrelated, and it looks really cool when you have it all drawn in. So don't worry about that. Yes, ma'am?
It's x equals the equations times y squared.
Correct.
So what did you do?
What do you mean, what do you do? Is it a y squared or an x squared parallel? It's a y squared parallel, so I'm going to write down the generic equation. Y squared equals 4px. And what do I set 4p equal to?
3x, never mind.
4p has to equal 3/4.
Wouldn't you get some negatives in there somewhere from moving stuff?
I'm not moving anything. What did I move?
Please explain yourself, or else I will get everything wrong and doubt myself.
I didn't move anything.
Give him a chance.
I haven't moved anything. The only thing that's moved is that the y squared is on one side, the x squared is on the other.
Would you have to move those to each other side?
No, does that mean the same thing?
Well, 3 over 4 times y squared is different than 3 over 4 times x, isn't it?
Right, but I'm asking you this, is x squared equal 3 and the same thing as 3 equals x?
Yeah.
Okay. Is this an x squared or a y squared equation?
It's a y squared.
Okay, so I wrote down the y squared generic equation. What's the coefficient of, now I see where you're getting at.
Yeah.
Okay. To get y squared by itself, what do you have to do? How do you move it?
You subtract it and
That's multiplies.
divide.
How do you divide a fraction?
By the
Reciprocal. Oh, I see where you're going here.
yeah.
Okay, thank
So
you.
guys, yeah, sorry, I see where you're at now. This is where some of you guys were screwing up before. To undo multiply, you don't subtract, you divide. You multiply by reciprocals, okay? So now that the 4p value has to set equal to 4/3. Which is the same thing as to undo the 4, multiply by 1/4. So p is going to get you 1/3. There's your p value. Okay. Yes, sir.
And the last one, that we did, generic was y squared equals 4p.
Yeah.
Stays the same.
Yes, sir. Okay. So if my p value is 1/3, my origin is still at 0, 0. P value is positive, it's y squared. Which direction is it going? It's going to the right again. Very good. It's going to the right again, so I'm just going to kind of... I know it's got to do this. There's my origin at 0, 0. My p-value is 1/3. Where's my focus? It's at 1/3 and 0. The directrix is at what? X equals, thank you. X equals negative 1/3. So I'm equidistant to my vertex. And then lastly, it's just to figure out something that would work kind of easy to get a point. Use 1, you're at 1 and what is that? 3/4. Or 1 and negative 3/4. Oh, I'm sorry, I looked at the wrong one. If it's 1, you get 4/3, but that's through y squared. So here's what I would do. Go to your calculator. Use your table function, guys. Use your...
Do the tests without calculators?
I thought you said we'd have the dump calculators though on the test, so why, how would we be able to use the
We
table?
didn't say we would try to figure out let us use it.
Yeah.
Oh.
Well, then you can see meanings of people like
Why don't you guys not worry about everything right off the bat, okay? I'm trying to show you how to do this. Just use your calculator. You're working with fractions because I know you guys don't know how to do that. You have problems with fractions. Just type it in, 4/3. And hit X. Where's, oh, okay, I lost there. And go right to your table. It should spit out, look for something that works clean. 3/2. Then what would be the symmetric twin? 3 negative 2. Very good. Okay? Yes, sir.
On the y squared equals 4px. With the y squared,
Nowhere. All I did here is I identified that I have a y squared here, so I use this y squared there. In this equation, I want to get y squared by itself. So then this coefficient set equal to 4p. And that's how you find p value. And that's how you do it whether it's an x squared or a y squared. Let's see. Let me do another one here. X squared equals negative 20y. We'll walk you through another one. Is this x squared or y squared? It's x squared, so this is going to be either up or down. So the first thing I'm going to do is I'm going to write down that it's x squared equals 4py. Now, is x squared in the problem already by itself? Yes, I don't have to move anything away from it. So that means I can just take the coefficient in front of the y and set it equal to 4p. Okay? Right. I know that, bless you, negative 20 has to equal 4p. So that means that negative 5 is p. Just plucking the coefficients out. Excuse me. This is an x squared parabola. So this is going to either go up or down. P is negative, so what direction does it go? Down. Down, very good. I know this has got to open downward. Vertex is still at 0, 0. The p-value being negative 5, which means my focus now is where? What's the order pair for the focus? 0, negative 5. Where's my directrix? Good, y equals 5. And then lastly, to get a set of easy points. Well, if I move stuff around a little bit, to make something very easy to work with, let's say it was, because I'm going to have to take the square root of 20. Okay? I'm going to have to take the square root of 20. don't freak out that I'm trying to get an ordered pair here that's going to give me a negative value. What we're looking at is if you were to put this in your calculator to get the y equals, you'd have negative 1/20th times x squared. That's how you put that in your calculator. You can get your table. If I use 5 times 20 would be 100. Square root of 100 is 10. So 510 would be one you can use, and there would be negative 5 and 10. Those would be my ordered pairs. 510. Okay? I just picked something I knew if I took the square root of it, it'd be very easy to get. Yes, ma'am? It should be x.
Like what we said.
Because we said, can we move that around? Oh, did I do that backwards again? Darn it. I did, didn't I? I was. Yeah, I'm sorry. I did that backwards. If you used, let's see, what's the easy one? 4, something divisible by 2. Yeah, if x is 10, you said it that way too, didn't you? You said 10 and 5, right? I wrote it 5 and 10. Okay? Yeah, if you use 10 for x, what's 10 squared? What's 100 divided by 20? 5. I just flip-flop. We're just using a table for right now. Okay.
Yeah, I don't know. But on the table it says x is negative 5.
Yeah, it can be either one, because you have a negative one on the side of that problem. From the symmetric places, you have both sides. Yes, sir?
Okay, on the next test, can you make it more fun and use like the words pentmobile in an equation or like a word problem?
Let's work through the other stuff. I got 2 more examples and you guys are running out of time. I'm going to write the equation given just a directrix.
No p is negative.
Is it positive or negative? How do you know?
If y is positive 2, then that's the direction that seems like above. And then the opposite of that is your p, so it's negative.
Very good. So what direction is this opening? Very good.
Down.
Very good. That's absolutely perfect how you explained that. What she was saying here, guys, is that knowing where the directrix or what a directrix is, it's the horizontal line. In this case, it's horizontal because it's the y equals. If y equals 2, it's up top. I know that my vertex is at 0, 0, which means my focus has to be down here. So your focus would be at negative 2. The p is negative 2. I know that since it is a left and right for the directrix, it's got to be opening this way, because remember, it always opens to the focus. So it's an x squared equals 4py, and our p value here is negative 2. So 4 times negative 2. So it's x squared equals negative 8y. And that's the equation. Okay. We do basically the exact same thing if you are given an ordered pair. Okay? If you're given an ordered pair, let's say you have negative 3 and 0, because everything's centered at the origin. If I have an ordered pair, can I go to another page real quick? If I have an ordered pair of, this is a focus, it'll tell you what it is, at negative 3 and 0. If my focus is at negative 3, 0, what direction does this thing open? Well, where's negative 3, 0? It opens to the left. Everything's centered at the origin, and it opens in the direction of the focus. So it's got to do that. If that's my focus, what's my value of p? Is it 3 or negative 3? It's negative 3. Okay. It's negative. And now, since it's opening to the left, is this an x squared or a y squared parabola? It's y squared. X squared are up and down, y squared are left and right. and you're done. You're able to set these things up given specific values. Now, it's gonna, what you're doing also is the same idea as we get further into this and we start looking at given a vertex and a co-vertex that we'll talk about tomorrow. We're gonna be looking at different sets of ordered pairs to be able to work through diagrams, to be able to write out equations with not too much of a hassle, okay? The idea here is understanding what this means. The p-value is always, 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 always the distance from a vertex to the focus. P will always be the distance from the vertex to the focus. So everything we're doing today, centered at the origin, 0, 0. If it's negative, if the ordered pair is -3 and 0, I just put a dot. That tells me P is -3 because it went to the left. If it goes up, it's positive. If it goes down, it's negative. If it goes right, which is weird because I'm pointing to my left, it's positive. Okay? Kind of follows along the lines of number line. Want to try a couple? What were the numbers I did? Ooh, forgot the numbers that I did earlier. So I cut it. Do those, please. There are 4 of them that you'll do the graphs. There'll be 4 of them that you'll write the equation given the directrix. 4 of them you write the equation given the focus.
So we don't have to graph both, just want the equation?
For the last 8, yes.
Okay.
The first 4 are just your straight boring graph ones. Yeah, it tells you exactly what they're at. Okay? Yes, sir.